Hi guys, in today's video we are going to explain how to prove the Pythagorean theorem and its converse. To start, we need to remember that the Pythagorean theorem is for finding side lengths in right triangles. To use the Pythagorean theorem, we need to know parts of a right triangle. In this diagram, we can see that the two shorter sides of the triangle are called the legs, and the side opposite of the right angle is called the hypotenuse. If you have a right triangle and you square the lengths of the two sides that make up the right angle and add them together, you get the same number you would get by squaring the other side, or the hypotenuse. The Pythagorean theorem says, given the right angle with legs A and B and hypotenuse, then a squared plus b squared equals c squared, which is how we get our theorem, a squared plus b squared equals c squared. And it's important to note that the hypotenuse is always the longest side. It's also important to note that A and B are supposed to represent the legs, and C represents the hypotenuse. Now, we are going to prove that this theory works using concrete models of square grids. These square grids are used to indicate the length of the side on the triangle. They are indicated by small squares to help remember that we need to square the number. So here is an example of the 9 squared, so that would equal 9, and this one's 4. Let's start by taking a look of this first right triangle. The square with 3 squares matches the length of this 3 side. And the square with the 4 matches the length of the other. Now, in order to find C, or the hypotenuse, we are going to plug in what we know into our formula. So here is our formula, a squared plus c squared equals c squared. And then when we plug it in, it should look like 3 squared plus 4 squared equals c squared. At this point, it does not matter which number is representing A and which number is representing B. Now we are going to solve for c squared by squaring 3 and squaring 4, which would end up as 9 plus 16 equals c squared. Now we are going to add the 9 and 16 and come up with 25 equals c squared. Then we can take the square root of each side. The square root will cancel out squaring c, and the square of 25 is 5, so we get c equals 5. Now we can prove that this is true by taking out the square grid and seeing if the 5 measured matches up. And we can see that it does, and all the measurements are exactly the length of the triangle. Since we just proved the Pythagorean theorem to be correct, we are now going to prove that we can use the grids to prove that we can find the measurement of a missing leg when we are given the hypotenuse and the other leg length. So here, we can see that the square of 6 grids matches the length of the side with 6. And the square with 9 grids matches the hypotenuse of 9, and we can see that it matches perfectly. So now, since we have the matches, we need to plug in what we know into the formula. So our formula again starts as a squared plus b squared equals c squared. Since we know that the hypotenuse is 9 and the leg is 6, we can plug it into and we're looking for a, we can plug that in and get a squared plus 6 squared equals 9 squared. Now we need to solve for a squared. We do this by squaring the 6 and squaring the 9, which would give us a squared plus 36 equals 81. Then we need to subtract the 36 from each side of the equation, and we would have a squared equals 45. Now we have to square both sides to get rid of the a squared, which would give us the square root of 45, which is equivalent to 6.7. Finally, we can prove this is true by matching the square grid and seeing that the grid with 6 full squares and a portion of the 7th square matches a squared, and we can see that this theorem is proven. Thanks for listening, and I hope this video showed you how to prove the Pythagorean theorem with square grids.